Udah. Yes, Keiko, I can see you. Can you hear me?
Yeah.
Sorry, Kyoko. Sorry, Kyoko. Okay. Oh, yeah, we're going to talk about the schedule later, right? Okay. Um, can you put the phone stand? We'll continue going through the exam paper lah, the analysis. Yeah. Sorry, Keiko, did you call? Sorry. Kyoko, did you call?
No.
No, I can see. Okay, wonderful. I think it's better to print. Okay. You have not continued from last time we meet lah, yeah?
No.
We were doing CG, right? And then that was the hard question. So how I suggest you deal with it is that you predict enough and then move on, right? At least you will not be able to finish that question. Let's pretend that is an exam. Does that mean that?
What?
You predicted maybe only half of the marks for the difficult PG question, right?
Oh yeah.
Question for look at the CG question for a while. Okay, now you only predicted how many marks? Two, is it? Two or three, is it?
3.
One, is it? Okay, 2 plus 1. Okay, 3. Okay, there are definitely more than, I don't know, 7 marks maybe here, 7 or 8 marks. Yeah, I think, yeah. Okay, does this mean that you will not be able to get the remaining marks if you just predict, 3 marks lah here?
What do you mean?
Like you're gonna do the 3 marks, right? During, let's say this is an exam, you're gonna do the 3 marks and then you move on, you move on to the next one. Let's say the next one is linear law lah. And then after linear law, you move on, continue. Does that mean that we are abandoning this question?
No.
Why is that so?
Like you mean during exam or what?
Yeah, during exam, not doing learning. Learning, of course, we don't abandon. I'm going to explain to you later, but during exam. Is that what we were doing? Are we abandoning this question because it's hard?
I don't know. Depends on what I think during the exam.
Then let me give you some possible scenario in exam, right? In exam. You're going to do everything else, and then you're going to come back to here. Obviously, if you have time, that is what you're going to do, right? Obviously, correct or not?
Yeah.
So, I have time at the end. I have 10 minutes left. Oh, that's not so bad, That's not so bad. I'll come back here and see what I can get. Let's say there are 2 difficult questions, and this happens to be, I think, still the easier one. Let's say we compare. Okay, you'll come back to this one, spend 10 minutes, and just try to get more. So in that case, you're not abandoning this question, no? Right? How about another possible scenario? Another possible scenario is that you finish everything else, but you don't have enough time to come back here, lo. Okay, that's another possible scenario, lah. Is that a bad thing, lah?
No.
But why is it not a bad thing? I thought CG is your, your strong topic. Wouldn't you feel bad?
I'll probably think about just scoring for other questions first.
And to me, I will agree with you because you're avoiding something hard, lah. That sounds bad, lah. But in exam, that is what you're supposed to do, lah, because the time is so limited. The time. The other possible scenarios, lah. You force yourself to do this, and therefore you lose time for other questions. That's another possible scenario. I think we should try our best to prevent that scenario, lah. If we can agree on that, we can work together more easily, lah. If not, you will feel bad abandoning something that you thought will be easy, lah, something like that. Okay, what do you think? Can we agree on that?
Yeah.
Okay. So next time when you analyze a question, not when you do it, when you analyze and you realize, oh, this question is different from the usual one. Your sensitiveness is you're alert. Okay, what's going on here? Is this actually difficult? You analyze further and you realize it is difficult. This is what you do, nothing complicated. Having said that, do you want me to explain this question right now, or should you wait until you do everything else?
Explain as in what?
You notice that finding the point D can be hard, right? It can be hard, isn't it?
Mm.
And I'm trying my best not to reveal to you what to do. That's not something I usually do, right? Something I usually do is to explain to you how to do it, right? Oh, this, that, this is that. But I'm not doing. I mean, I have to do certain things because you're just very rusty, lah. For example, your your shoelace is very rusty, so I have to do that. But I'm not explaining to you how to do for part D, lo. Should I just get it over with right now, or do you want to wait until other questions are settled?
Right now,
But why do you want it right now?
I don't know.
If you can, wait, just because of one reason. Because that is what you're going to do in exam. You have to put this behind. So we put this behind, not so that we can abandon it, but in learning, we learn it later lah. We pretend that this is like exam law, something like that. Okay, we wait lah. We wait. Okay.
Okay.
So that's the reason why I think it's good to wait. Now, moving on to linear law. You look at linear law for a while, just to confirm everything is clear.
Yeah.
Yeah, you were also kind of rusty back then, but I hope you have some revision. So back then I realized that you are rusty in many topics, but that is to be expected one. You have been practicing, other topics. So the last topics, even though you're supposed to be strong, you are rusty right now. I'm very happy that we're doing this right now, not near prelim, for example. This is a good time to revise. So what I'm saying is for the next topic and the next topic and the next topic, if you feel that you just want me to revise with you, well, then I will revise to you. That means I will break the rule and I will simply show you or tell you how to do it. So this is not like your best analysis lah. Your best analysis should be like, you do it more yourself. I just hint you. But I will break that, especially when you realize you're very rusty lah. Okay, you understand me? So that you're not stuck. We have to revise anyway. And then holiday is a very good time to revise because you're not push and pull by so many things. So just to clarify, do you want me to revise this linear law? One more time. Do you need me to? Or do you know how to do it?
Yeah.
Okay. And just make sure that you go to the next topic. Just make sure if you want me to revise something, just make sure, right? I'll break the rule. I break the rule. Aiden, I can see you. Can you hear me?
Yeah, I can.
Aiden, I have surveyed one paper. So if you want to do a Sec 3 paper, I send it to your WhatsApp already. The numbers that I think you can try. Quite various. They're quite various lah in their topics. They even have 2 or 3 QAs. So that one. Do you want to do that Sec 3 or do you want to run directly to Sec 4?
I can do the Sec 3 first.
All right. Then for warm up today, please do so. You need a new Jamboard, I tell you already. So, share with me when you're done. Tell me, I can go in.
Okay.
Then, as per usual, copy paste to the Jamboard. Then I can follow you. Okay, go. Do you need any revision? Okay, let's not go. Let's not go using the number order. Use your order. Okay, use your order. Okay, use your order. After linear law, what? After this, what? After this, what? After this, what? Your order.
Huh?
your order of revision, your order of reading, yeah, Kyoko, not the paper's order, okay?
Yeah.
Circle. Goodness. This is not circle geometry, lah. This is the last topic. Have you covered this circle before?
No.
Then ignore this question. Ignore this. This is the circle geometry. The circle geometry is okay, Aiden, you have shared the Jamboard. Please tell me.
Yeah.
All right, so just copy paste the question. Okay, Kyoko, do you need a quick revision?
Maybe.
Okay, remember this for circle question, yeah? This is circle geometry, lah, yeah? The drawing is absolutely important for you. There is no drawing here right now, right?
Yeah.
Better draw and in a rather accurate way. No need to be 100% accurate, but you want your points to be accurate. You want your scale to be accurate. And you want the line to be rather accurate. Because you are the type that will be able to see the solution from the drawing, or rather at least be inspired. Okay. This is 7 marks, right? 7 marks. Yeah. So not gonna happen unless you draw and, so to speak, help and inspire yourself. You understand, Kyoko? So in your analysis, draw lah. Like really draw lo, and in an accurate way lah. Okay, Aiken. Any problem copy pasting? Yesterday you were doing very well.
No problem.
Okay, today your video not so clear, yeah, Kyoko. So sometimes I will ask now, are you sure you draw the center point accurately and the line accurately also? Are you sure? It doesn't feel like the line is I mean, yeah, your line is a little bit terrible. It will mislead you. So that's what I mean. That is definitely not, well, cannot say definitely not lah. It's, I mean, first of all, you draw your line passing through the 0, 0, right? That can be misleading. Can be misleading. Are you sure that is the right line? Again, I implore you, draw the line rather accurately, please. It's not a sketch. It's not just a sketch. You can be easily misled like that. Oh, the way you, wow. Yeah, I'm at this point, I'm very, oh, wow, no. Oh, no. Oh, I know. Sorry. I misread your drawing. I think your drawing is misleading because the other line crosses the first line at 3,5. Is there any reason to do that? Just to confirm.
It says it's a normal to the circle.
Yeah, but at the same point, really? That is how you understand the question. Like you have 3,5 as tangent. Totally agree with you lah. Totally agree with you. Then the second line is normal at that point.
I don't know. I just draw there to assume first.
No, what you draw is, it seems to be like that, lo. You normal it there lah, something like that.
Yeah, because I don't know where it is.
I agree, but what you can do is you can draw something rather accurate by that line, which you didn't. You didn't at all. I think the first line is rather accurate. I like that. The second one is not, and it is totally misleading. Would you please draw the second line accurately? If you need a revision on how to draw a line, please tell me. Please tell me right now, okay? Now for Aiden, let's not put too many questions. Okay, okay. That's a lot of questions for one page already, right?
Okay.
Maybe we use another page, right, after this. Okay. Oh dear. Okay, go. Come on. Do you need a revision on how to draw a line?
Yeah, okay.
First, make the subject Y.
Yeah.
So do that. Make the subject Y. Make the subject Y. Got it? Yes. Yes. Right. Only then you are more familiar with how to draw this. You cannot draw the one on top. You will be wrong. This one on the bottom, you can see the gradient and the y-intercept, right?
Yeah.
And you use that to guide you. And please erase the wrong line. I think the line is very wrong that way. The circle, you also, I think, just draw the circle later lah. Yeah, it may be confusing lah. Just keep that in mind first. Okay, maybe it's like that, right? Maybe the circle is like that, but don't be so sure about the circle yet lah. Yet lah, not yet. Yeah, draw the circle later one. Okay, later. Draw that line first. Yeah, maybe something like, okay, fine. So now look at your imaginary circle. Is your imaginary circle kind of maybe correct? Something like that. Yep. Let me tell you something about your imaginary circle. It will be the best if you can discover the center of the circle. Now that is the great thing about circle question. The center of the circle is the most important thing, and they never tell you one. It means you have to find it. Just by your drawing of lines, you see the center of the circle already. If you cannot, then of course it's harder. But if you can, focus on that center of circle first. Do you see it? The center of the circle. Is it visible from your drawing?
No.
Okay, now here is the last basic revision of circle. First one is you must draw, especially for you. You must draw accurately, right? Your second revision just now was how to actually draw a line, and you are currently correct. The third one is finding the circle, right? Finding the circle is usually easily done by intersecting two normals. Tell me, does this sound new or not?
No.
Hey, do you have two normals?
Maybe.
No, maybe. Yes or no? Do you have two normals?
Yes.
Their intersection is definitely the center point of the circle, which is the most important point in any circle question. Do you have the center point?
Yeah.
Okay, then label it lah. Label it C lah. A center point is also always labeled C. Okay, and if the best news is that after you have the center point, you have the radius. No? Do you have the radius visually lah? Aiden, are you stuck or are you copying questions?
I'm doing the question.
All right, okay. Okay, hey, good. Okay, let me check. We have the radius. Yep. Kyoko, third time already. Can you see the radius or no, you cannot see any radius?
No.
Yes, you can. Let me give you a hint. The radius is between the center point, correct? And a point on the perimeter, lah, correct? You have a center point. There, you just don't know the coordinate. You have it. That's a lot of difference than simply don't know where. Do you have any perimeter point?
Yes.
Then, if you have a perimeter point and a center point, don't you think you have the radius?
Yes.
Okay, then where is the radius? Do you see it? Label it, please.
Yeah.
Then label it, label it. I never asked you to find the radius. Wrong, wrong thinking. That's a doing thinking. Seeing the radius means you are sure you are able to do it. You don't have to do it to find out. Wrong thinking already. In this case, for example, you should be sure that you can find the radius. Do you know why? Do you know why?
Because we have the center point.
You have the center point and the perimeter point. A radius done? Make sense or not? You don't have to do it so that, oh, I can find it. Wrong thinking, wrong way of analysis. Wrong. You should know when you see it, oh, I can. Now let me ask you, how come you are so sure you can find the center point? Because you
two lines.
Because not two lines. Say properly. What kind of lines are you referring to?
Normal.
The two normals. Are you sure you have the two normals?
Yeah.
You have one. The other one, are you sure you can find?
Yes.
Then you are sure you can find the center point without actually doing it. That's analysis. Do you understand?
Yeah.
Now, at this point, for 7 marks, how many marks can you get? Do you still have to analyze more or can you predict your marks already?
I don't know.
Then analyze more. Then analyze more. But I'll give you 2 or 3 more minutes. If you need revision, you tell me immediately. I don't know how rusty you are with circle. Okay? Tell me immediately if you need help for revision. interesting. Now, for 14, Aiden, tell me why you think A.
Because copper is blue.
Okay, correction, not copper, but in this case, copper 2+. This time we become very specific, copper 2+. For example, if you say copper only, I would think you refer to copper metal. Now, copper metal is not blue, right? Copper 2+, correct? Is that what you're thinking?
Yeah.
Okay, but are you sure there is no, for example, green precipitate?
Sulfate is not green. Sodium is not green. Carbonate is not green.
Very good. Now let me ask you, what is the color of carbonate or sulfate or sodium?
I'm not sure. I didn't know that. I need to know the color of it.
Let me tell you the big secret lah. Most of aqueous stuff, in this case, the carbonate is aqueous, right? The the sulfate is aqueous and the sodium is also aqueous, correct? Yeah?
Yeah.
Most aqueous stuff, if they never tell you the color is colorless. Colorless. You don't have to guess. The reason why they don't tell you is most of the time, 99%, it is colorless. There's so many colorless things, so to speak.
Okay, then where did the green come from?
Well, no, there is no green. I was just testing you, man. Do you think there's a green? No, you say none of them are green. Well, you are correct. You are absolutely correct.
But then when I saw the answer key at the back, the answer key wrote the answer was D.
A green precipitate and a colorless solution. Oh my goodness, I forgot something. Right, there you go. Yeah. Now, this is something that we should have done at the start. At the start, without analyzing anything else, you would notice, hey, how come my state symbol is missing? Like something like that. Now, you think about it. Do you realize that CuCO3 is solid? Now that you think about it, do you know that?
Yeah.
Okay, so everything else, just to confirm?
Everything else, Na2SO4 is aqueous, right?
Sulfate, well, everything, what you will memorize is everything with sodium plus is aqueous. Am I correct? That's what you memorize?
Yeah.
That's why, for example, the sodium carbonate is also aqueous, right? Now, for the precipitate, we become a little bit more careful, and this is unfortunately a color that you don't know. Oh my goodness. Now, for all precipitate colors, when they don't tell you, usually it's white. So one more time, for aqueous colors, when they don't tell you, usually it's no color. For precipitate, when they don't tell you, it's usually white. Okay. Now, you think carefully. You see one precipitate here. So usually, I don't know the color of CuCO3. A teacher never tell me. You are correct. You are correct. Have you seen this in lab? I don't think so.
Yeah, I haven't seen it.
Now, think about this question. Is it a problem that you do not know the color of this precipitate?
I think it's a problem because they are asking me for the color.
Now let me tell you, it is not a problem because the two option is green.
One option is blue.
I'm sorry?
One option is blue.
No, green precipitate and blue solution. Your problem is the color of the precipitate. You don't know the color of precipitate. But you should realize that there is a precipitate. Therefore, first of all, A and B cannot be right because there is a precipitate. You look at C and D. It's a green precipitate and green precipitate. So that means you don't need to know color of the precipitate. Just know that there is a precipitate.
Oh, so the green part is not in the syllabus.
No, they will not tell you formally that CuCO3 is green. They don't, and you wouldn't know. Maybe until exam you wouldn't know. But I'm telling you, because this is MCQ, you look at the option, it doesn't matter. What matters is you don't forget that there is a precipitate. Fair or not? Fair?
Okay.
Now, then you only have to decide whether you are left with a colorless solution or a blue solution. Now, that one you have to decide. Okay. Kyoko, sorry, for the circle question, have you predicted your marks? If you have not predicted your marks, that means you are not settled in your analysis. Have you? If you haven't settled, just ask me for help. Do you need help?
No.
Okay, then predict your marks. Out of the 7, how many will you get? That's how you say you are done with your analysis or not done lah, huh? Your prediction. Okay, Aiden. Now, Aiden, you think it's D. I mean, to be fair, don't look at the answer key first before we discuss lah, huh? Before. Now, D is wrong. Unfortunately, you need to know the reason why, lo. So the colorless solution is the problem, not blue. Now tell me, just to be clear, Na2SO4 is colorless, lah, correct?
Yeah.
So the reason why the color blue is still there because there is excess, and that's something you didn't take into account. There is excess on the left-hand side. Now, do you understand what I'm saying just now? Did you understand?
What do you mean by there is excess? Because there's no option there, right? Green, blue, and colorless.
No. When it's colorless, and there's another color, the colorless become blue. Lo. There cannot be
the blue dilute in the colorless solution.
So meaning the colorless is no more lah. The solution is still blue lah, if that makes sense. Now, when I say excess, I mean just like the salt preparation. No? Remember, most of the time we want when one is excess and one is gone. Correct or not? That's what we want most of the time because that's the easy way of doing things. Remember?
Yeah.
Okay. Then predict the next one, yeah, Kyoko, yeah. So in this case, if you calculate the mole, the mole of the copper sulfate is 0.004 mole. Then the mole of the sodium carbonate is
Mole of sodium carbonate. 0.004 as well.
Oh, right. Now we are certain. Oh, goodness me. This is not the normal thing. This is excess, one gone, or this is what you will call a titration.
Okay.
No, that's the question. This is more like a one excess, one gone, or this is more like a titration where both are gone.
You said that there was excess, right?
No, that's the normal assumption until you check the mole.
I think there's no excess because like 0.004 on the other side as well.
Correct. So 1 ma, correct. The number will say 1111 lah, something like that. Correct. The balance lah. Hey, so there is no what do you call it? There is no excess. Hey, both are gone. That means will there be a blue solution?
If everything is gone, then there's no excess to make a blue solution.
Therefore, the answer is
Colorless.
something like that. Now, you are only sure about that when you finally calculate the mole. You're only sure. Will this be okay?
Yeah.
All right. Please continue. Okay, Kyoko. We're going currently. You have 3 marks in your thing. So you think out of 7, okay. So that's 3 marks. Now, how about part 2? You're stuck. Now tell me what you're stuck. Let's not do too long here. Okay, tell me what you're.
I don't know where the point can be.
Nearest to the x-axis. Okay, first of all, you don't get what I'm saying. I'm saying draw the circle accurately. You are not drawing the circle as accurate as possible, therefore misleading yourself. You know the radius and you know the center, quite roughly lah, but the circle therefore shouldn't be like this. Can you please draw a better circle? You're not being accurate and therefore it's very misleading. Now, if you don't know what I'm saying, go and take a compass. Look. What else can we do, right? We go and take compass up. least you know citric acid is acid. What? Aiden, for question 16, why do you think it is C?
Because it's the same as ammonia gas. It's the same as ammonia gas, whereby like you need it to be moist for it to actually have a reaction.
Fair enough. Oh, but it's dry. Wait. Is this going to be a trick question or not? Because the air have water vapor. No, you're right. No, you're of course right to say that dry means no water lah. You're absolutely correct. However, there is water vapor in air. 5 minutes enough or not? The question is so tricky, man.
But water vapor won't affect it, right?
It will, but extremely slowly. That means the dry crystal will tend to absorb water vapor from air. Do you know this? Oh, you don't know. Oh my God. Never mind. Sorry. Let's give it the benefit of doubt. If this is after 5 hours, it will happen. This is 5 minutes. Let's give it a benefit of doubt and say you are correct. It will remain unchanged. Fair enough. 5 minutes is not enough. Yoko, do you have your compass? No, it's going to be a very small distance. So compass is not ideal. But what can I do? You don't seem to imagine the circle properly, and that misleads you. So with great effort, please draw the circle. Please draw the circle. Okay, it's going to be difficult, yeah? But what to do lah? What to do? What? What? Sorry. For 17, Aiden, why is your answer C?
Because oxide plus ammonium salt will produce ammonia gas.
That's not true at all. Sorry. When do you study that? Huh? When?
What was the simple formula that I learned? Like an ammonium salt plus another base or another alkali will produce ammonia plus salt plus water.
But it's not calcium oxide. Did your formula say calcium oxide? As in oxide, sorry. Another base or alkali, right?
Yeah.
He doesn't say anything about oxide. Oh dear.
Oxide is a base, right?
No, that is correct. No, that is correct. That is correct. The problem, what happens is this. Why is the formula correct? Is because of this NH4 SO4. So basically, if the base are strong enough to have OH or produce OH, they will meet and do the split law. Remember, the weak guy, like the weak guy. They will do the split into NH3 and H2O lah. That's why they will produce ammonia gas. Make sense?
Yeah.
Right now, calcium oxide is undecided. The question is tricky, isn't it? Wow. At this point, you don't know whether calcium oxide will produce calcium hydroxide or not. Oh, goodness me. You don't know. That's 2 chapters down the road. Oh, man. I guess that's what we get by doing SA2 lah. But guess we let it be for now. Okay, so Kyoko, the circle is more accurate, right? So yeah. Oh goodness. Okay, Kyoko, let's pretend first that the circle can be smaller or bigger than this. That's our, our adjustment lah, because our drawing is not very accurate. Okay, so far so good. Joko, don't be muted, please.
Oh, sorry. Yeah.
So because our not accurate drawing, the circle can be smaller or bigger. Now, the question is, find the corner of the circle which is nearest to the x-axis. Does this make sense if the circle is, for example, bigger, or if the circle is smaller by a bit? Which one do you think then it will make sense?
Uh,
Just try to draw a smaller circle just by hand, and also a bigger circle. But just now you have a bigger circle, so no problem. Just try to make it the circle smaller, so you have one small, one big. Just draw using another pencil. No need to draw the bigger one. Come on. Just slightly smaller. Okay. Yeah. So let's say this is the more correct circle. We wouldn't know, right? Now, this smaller circle makes sense or not for the question?
I don't know.
Make it even more, even smaller. Make it even smaller, Joko. Yeah, let's pretend this is very extreme, right? Now look at this small circle. Does the question make sense?
Maybe.
Okay, if that is a small circle, where will the answer be? Part 2, the the coordinate where it is nearest. Where is it? Something like that, right? Not sure whether that's truly correct or not, but roughly like that, roughly like that. Okay, so maybe we don't know. Maybe your drawing is not accurate. Maybe the question will be giving you a smaller circle. Then it makes sense. When the circle is bigger, it no longer makes sense. Is it what you're saying?
Yeah.
Okay, now let me tell you something. The big circle can also make sense, just I mean that means it's the point where it crosses the axis lah. It's crosses the axis. It's just that the phrasing is not very comfortable that way. So if you're not sure about this 2 mark, then leave it be and you predict it's 0 mark first. Hopefully when you do it, you can get it lah, but we don't know at this point. Okay, come, let's settle your analysis. Is there any other question? Is there any other question for this circle?
No.
Okay, let's move on. Let's move on. Oh. Okay. So for Aiden, for question 19, why do you answer B?
Because sodium chloride is aqueous and barium sulfate is solid.
Solid. And then the target is aqueous, right?
Yeah. So if I add excess solid, then aqueous stuff will dissolve already. Then I just filter out the solid, and then the aqueous sodium sulfate will come out.
You're correct. You're paying attention to the practical application. There you are correct. Okay. However, there is one problem. Let me illustrate what is the problem, right? For example, D is also solid and aqueous. Right? Also solid and aqueous. Then maybe I put it this way. How come you don't choose D? Same benefit as what you want.
If I add excess sodium metal,
So always the solid is excess, right? You can always do that one. So excess barium sulfate or excess sodium metal. Why do you choose B, not D?
not sure about this. Maybe because the metal is like malleable, ductile, something like that.
So you cannot powder it, then it'll be slower, right? So there is the disadvantage of metal until you realize part B. You remember what I say at first: acid react with base, base react with acid, correct?
Yeah.
B is salt with salt, salt with salt totally does not react.
Oh, but I thought this chloride is HCO. Now the chloride is HCl, and then like,
No, it's sodium chloride. Sodium chloride is not HCl.
oh, so it must always have like acid. So the
Yeah.
answer is B, although it's lower.
Correct. Because B, nothing happened, so to speak. Really nothing happened.
But why does the answer key say it's C?
Now let's talk about C because he say best method. Tricky question. So let me see. Oh, B cannot first, but let's agree on that B cannot first. Can ya? Because no reaction. Salt cannot react with salt.
Yeah.
Will have a reaction, but it will be slow. Granted. Now let's talk about C. Let's see. Sodium hydroxide to sulfuric acid. Oh goodness. So this guy, what is the problem with this guy?
Which one?
What is the problem with sodium hydroxide to sulfuric acid, if there is a problem?
They're both aqueous.
Yeah. So in order for aqueous and aqueous to be successful, what must you do? You must do titration, which is a very slow process, right? So now it is our choice between C and D. C is slow because titration. D seems to be slow because of metal cannot grind whatnot. Can? Yeah. Now, coming another practical consideration. So metal once kena water. Remember, the sodium metal will be immersed in water, correct or not? Have you seen a sodium metal in water reaction?
It will corrode, is it?
It will what? Sorry?
Corrode.
No, it won't corrode. It will catch fire and then explode.
Okay, I've never seen that.
Oh dear. I'm sorry, I'm telling a lot of practical applications. That will happen. Sodium metal is so reactive, not other metal, okay, not copper metal. But sodium metal is so reactive, if you just put it in water, after a while, it catches fire and then explodes.
Oh.
Now, it is even worse if you add acid. The explosion is much greater, such that it will splash everywhere. That is actually dangerous already. Very dangerous already.
Yeah.
So sodium metal to sulfur acid is good on theory. Something will react. It is actually surprisingly not slow, but surprisingly very fast until it is explosive. How do you know all this? To be fair, 2 chapters down the road, you'll learn this kind of thing, no? The speed of reaction, to be fair. So right now, maybe you don't know, fair. So you look at C, sodium hydroxide to sulfuric acid. Actually, the titration is the best thing because it slows down a fast process. If you just dump sodium hydroxide and sulfuric acid, pour like that, it will also explode. Literally explode. The titration is there to help slow things down. So surprisingly, the titration becomes something important if you want to deal with sodium hydroxide and sodium metal. But forget sodium metal. Sodium metal is dangerous. Forget it. Thus, the word dependent. B cannot work. D too dangerous. C is the best.
Yeah. I also have another thing about when you said salt and a salt cannot react. But why is it that in question 14 there's a salt reacting with a salt?
Okay, now let's check. First thing first, it is not salt reacting with salt. It's not. I know this is called precipitation. It's not, yeah. First of all, this is two aqueous salt. Two aqueous salt, be very clear. This is not an aqueous salt and a solid salt. An aqueous salt and a solid salt have no chance of reacting already. Now let me explain the 14 one. Now you are correct in asking all this. You are correct. Now the aqueous means, remember what aqueous means? Tell me. I tell you already. What does aqueous mean?
Aqueous means titration.
No. Aqueous means is split in water. That's what it means. Aqueous means it is split down to the smallest possible thing. Remember, we talked about it. Aqueous means, I split down to the molecular level, therefore I have the highest surface area, blah, blah, blah.
Yeah.
That's what aqueous means. Now, solid means the other way around. No? I have the least surface area possible, right? Because I refuse to split. So let me draw the split for now. Cu2 plus or 2 minus. Kyoko, are you stuck currently?
No.
Do you want to write something or do something?
If I write something, I'll probably do the question.
Just write the first two steps. Okay, let's solve this tension. The tension of you, feeling like you want to do, but you are not allowed to do. Just write the first two steps and then stop and then see how you feel. The purpose is to predict your marks. Would that be okay?
Mm.
Okay. If that's how you feel, write the first two sentences. Okay? The first two lines. Okay, let's call it like that. Okay, now Na plus and then CO3 2 minus. Okay, so Cu2 plus, SO4 2 minus, Na plus, CO3 2 minus flying around. So far so good?
Yeah.
Now, according to the solubility table, when any carbonate is insoluble for certain exceptions only. Most carbonates are insoluble, correct?
Yeah.
So when this carbonate flies around and meet the other guy, the Cu2 plus, they, strictly speaking, this is not a reaction, no, this is a precipitation, no? So they become solid. Again, strictly speaking, this is not your normal reaction. It is a very soft, just let it become solid. Simply because they meet and they decide, oh, I'm a solid guy, I become solid.
Oh,
This is what we call precipitation.
Because copper isn't in group 1, so when you mix with CO3, it becomes solid. Correct.
Again, that's reason. The first reason why they meet because they split and then they fly around, or they meet and then they join hand, so to speak, and reduce their surface area. This situation is only possible when originally both are equals.
Oh.
19 is not like that. Furthermore, it is not precipitation also because the target is equals. Totally cannot already. Definitely, totally just cannot already. B definitely cannot one. This is hopefully not a memorization, because if you memorize, maybe it's confusing. I know. Hopefully you understand it. Hopefully.
But why does it even react still?
Who react with it?
But why does 14 still react?
What do you mean by react? Okay, again, I explained to you, they do call it technically a precipitation reaction. This is, however, hardly a reaction. This is CO2 plus meeting CO3 2 minus and then joining hand. That's it.
Oh, so it's not a chemical reaction, it's a physical reaction.
You can, that's a very difficult line to draw, but it feels a little bit more physical than chemical. If you want that sense, yes. Yeah, it is more physical than chemical one. But your chemistry teacher will object to that statement. But I get what you're saying. It is more like that. It is definitely not a violent reaction, just to be certain. It's not speedy. It's just like just happen like that. Like that.
Oh.
Which, let me emphasize, the A19 condition cannot happen this one. Cannot happen one. Definitely cannot.
Okay.
That is what I want you to understand.
Yeah.
Right? Something like that. Yeah. That will be your first one, right? And agree. If you write this, I don't think there's any problem. Now, is there anything else that you can do?
Mm,
Fair enough. Can you predict your marks? If you cannot, I'll give you more things to do lah. Yeah. The reason is because you're very certain, right? Correct or not?
mm.
Now, let me ask you, how come it takes so long for you to, to write down that you think you'll get 5 marks? What's going on? Is it because you are not confident just now?
I don't know. I don't know what will happen if I do the paper.
Now, fair enough. Fair enough. Prediction is difficult for you. However, this is what you need. Okay, I'm forcing you to do it. Now, let's go back to GC. I'm not going to ask you to finish analyzing everything. Okay, it is painful at first. So why don't you now enter the time for doing CG, then doing linear law, then doing circle, and finally doing this. Is it the maximum minimum? I thought there's a tangent normal before this.
I,
Anyway, are you ready to do just the questions that you analyze? Just the question you analyze. Are you ready?
maybe.
For the marks that you're goaling, not the full marks, that's not what we are aiming for, right? We're just aiming for the marks that you are, you want to get. If you can get more easily, go ahead. If not, then we just move on. Okay. Let's just do it. It's very painful to analyze too long, right? Let's do it first. Let's get confidence. Come. Uh-oh. Okay, Hayden. A20, just to confirm, this is a QA question. Do you think so?
Yeah.
All right. Then tell me, why is the answer iron nitrate for you?
It's iron nitrate because when it says like colorless pungent, when it's mixing with aluminium and then it got warm and then NaOH and everything,
Correct.
that means that it's a nitrate. So like A is gone already.
Agree. Totally agree with you so far. Now, why do you choose B, not C, not D?
Because for not D, because zinc will dissolve in NaOH, but zinc will
You can look at the table. Don't memorize the table. Just look at the table. The table that we discussed or your own table. You can. Please look at it.
C is not in the table, so it's like, and then because potassium is like very reactive, right? So there'll be like obvious like bubble and everything. So C
I agree with you first that zinc is wrong. You agree, right? You also know, right? Table wise, right? Okay. Now, your choice of iron 2, however, I think I have to disagree because iron 2, no matter what you do, will always be green one. Isn't that
no visible change? Right?
I'm sorry?
That's why there is no visible change.
That is the problem is C will also have no visible change. Okay, let me explain what it means by visible change, right? So look at the table for a while, right? So let's say that this is an iron 2, right? And we all agree that the iron 2 is supposed to be green, right? Supposed to be green. So this guy is green. When they add NaOH and NH3, there is a visible change. The green solution becomes green precipitate. It's a very clear change. Am I making any sense right now? There is a precipitate before there isn't.
I don't get it. Like, I thought it's always a precipitate all along.
No, remember the solubility table. Solubility table says every nitrate is soluble. So it is not a precipitate. Initial solution Y, not a precipitate, a green solution.
Oh, so Fe2 plus is a precipitate, but when it mixes with NO3 minus, it isn't a precipitate.
Okay, let me correct your understanding here. Let me correct your understanding. Whether something is precipitate or not depends on the pair. That is your concept that you must get. You don't memorize that. Or Fe3 plus is precipitate. Wrong. It depends on the pair. It is really wrong to think that way. It's not an individual decision. It's a pair decision.
Oh.
So Fe2 is soluble or insoluble? No. Who's the pair? Or nitrate? Soluble. Carbonate? Insoluble. Sulfate? Perhaps soluble. I think sulfate is soluble, right? OH, definitely insoluble. You get what I mean? Depends on the pair.
Okay.
It's just that certain pair are very powerful. It's almost as if they determine. So I say, oh, nitrate oil is soluble. What they mean is whatever you pair with nitrate will be soluble. It's still a pair decision. Whatever you pair with sodium plus is soluble. Yeah, but it's a pair thing, you know.
Oh.
So B is wrong, but just because of the soluble and precipitate. Now,
C is also like.
Now C, let's talk about C, right? So anything paired with nitrate and anything paired with potassium are all soluble. You know, those are the two super pairs, right? Potassium nitrate is soluble. So no matter what you add NaOH, you add NH3, no matter what you add, it will always be simply soluble. Therefore, no physical changes. No carbon changes, no precipitate soluble changes also. So the answer is, I think, better C, I think.
But why is C better than B though?
Again, B is there's a precipitate change. From soluble to precipitate, when you add NaOH and NH3, they will both create precipitate. It's a very visible change. You see the powder drop down one.
So when I add FeNO3 to NaOH, it will form a precipitate.
From green solution to a green precipitate, the solution becomes more clear. It's like
NO3 is always a like aqueous thing. So how did it suddenly become a precipitate?
Yeah, because the Fe2 plus meet the pair of OH. When they add NaOH, it's NaOH they're adding. It's adding OH minus. Fe2 plus meet OH minus, they decide to solid, and there is nothing that nitrate can do. Nitrate is not all that powerful.
Then why is it NH3 also turns into solid? Because NH3 has no OH.
Surprisingly, NH3 is not NH3. Surprisingly, this aqueous ammonia is NH4OH. Same thing. It's also the OH thingy. They never explain to you all this. Now I'm explaining to you.
Shouldn't it be like H2O as well? Because NH3 plus H2O will only make that.
I know. NH4OH will split to NH3 and H2O. I know, but if you keep it in the right condition, you do get NH4OH in a reasonable time frame. I mean, it's not a very fast breakdown. So because of that, you will get OH minus. The same thing is what you get with NaOH. It's the same thing.
Oh.
OH minus is now the pair to Fe2 plus. They say, hey, how about we join? You say yes. He say yes. Immediately he say yes.
Yeah.
And again, that is why B you can predict to be, there is a visible.
Yes.
All good questions, huh? Oh, this paper really no joke, isn't it? Really no joke. Good. Thank you, Fu. Kyoko, you're stuck again, yes?
Mm,
Have you found the coordinates of C?
yeah.
Now, the word find, when you say the word find, let's be clear about the word find. Find means you have to give your working or not.
Yeah.
Wait, let me think for a while. Wait. To remember this correctly. Anyway, let's pretend that you have to do the working. You're stuck with giving the working, correct?
Yeah. No.
So why are you stuck here?
I'm stuck in this one.
But I thought you said that you're not going to do this. You predicted this is 0, right? No, me?
Yeah, but
You- There's so many habits that we have to fight, isn't it? We have to fight a lot of your bad habits, right? I'm forcing you to do what you do, yeah? You don't normally do, yeah? Write 0 marks and then move on. Come on. Write 0 marks and move on. This is exam. Dah, 0 marks. Go to part 2. You do part 2. For part 2, go and find point B and then go and find point C. You gotta write your writing on point B first. Do you know how to? Write down xb equals to 0. Write down. Xb equals to 0. Write down yb equals to ya minus 4. Come on, write down ya minus 4, which is ya is 2, right? So write down 2 minus 4 equals to minus 2. 2 minus 4 equals to minus 2. Right. So now write b bracket 0 comma minus 2. Write down b bracket 0 comma minus 2. That's your declaration about coordinates of b. And now yb equals to yc equals to minus 2. Bracket the reason bc parallel the x-axis. Right now, write down xc. Xc equals to xb plus 4. Okay, then c coordinate is what? Then done. Yeah, I cannot see. C coordinate is, yeah, write down the c, declare the c coordinate to be bracket. Yeah, c, just c bracket is enough. C bracket, just like the b, c, then bracket, good, bracket. Yeah, write out the coordinate. Okay, done. Okay, you okay?
mm,
There's 1 mark for you. You got it from your visual doing. I'm just helping you write. This is acceptable. Understand?
mm.
If this is new to you, then learn it lah. You must understand, you know how to do this visually lah, you know. But please continue. Okay. Ooh. Okay, for Aiden, 21 is fine. Tell me 25. Why is it A to you?
Because there is no NaOH and NH3, so they won't change color. Since I haven't learned like chloride change into what color in the syllabus, and then just now you go and say like, I should assume it's colorless, so I assume it's colorless.
Chloride ion definitely colorless, but how do you know? This one you know already. Because every time you put salt in water, it stays colorless. Ma? Now tell me what is salt? Salt is like your table salt, your normal salt, the one people call salt one. That would be
NaCl.
which in water dissolve. Dissolve means split into.
Into Na plus and Cl minus.
And the proof is in front of you. Cl minus is colorless. Make sense?
Yeah.
Okay, so you are right to say that Cl minus is colorless. This is zinc 2 plus. They never tell you the color of zinc 2 plus. Most of the time, they never tell you mean colorless. Colorless, 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 correct? This is your mistake, Lo. You're doing all the correct thing. Let me repeat this. You're doing all the, you're writing down the reaction, you're figuring out what happened. All these are correct. How come you forget that Cu2 plus is
Huh?
isn't Cu2 plus blue color? Blue solution in this case.
It's still blue, but it's not 2 plus now because now it's just writing like matter itself.
No. The copper is here. The copper is here. The copper is here. The zinc is here. Yeah.
Yeah, but this is not 2 plus. This is just the pure element of copper.
I know. And the resulting CuCl2 is Cu2 plus what?
Oh, that is like, I didn't really calculate this. My muscle memory, because I did a lot of like CUs, I assume it was this.
Yeah. Maybe you have to learn that. Remember, it was Cu2 plus that form. Is blue one. Again, the way you do it is correct. But I think you forget Cu2 plus. That's all. That's why the answer shouldn't be A. The answer should be, what should the answer be? The answer should be,
But the answer key wrote A.
Yeah, because the answer key thinks in the previous chapter, in the next 2 chapters, he will say that copper doesn't react with hydrochloric acid. Which one do you want?
Copper is unreactive, is it?
So copper is unreactive unless you leave it for quite a long time. Unless
If it's unreactive, it shouldn't even react, so there's no copper.
it is true that zinc will react first. That one is just confirmed, right? But there will be copper will react after some time.
The element of copper takes some time to react. But copper 2 plus can react instantly.
No, copper 2 plus doesn't react instantly. One more time. Copper 2 plus, first of all, is the result of the copper reacting, correct, right? Now, copper 2 plus, I'm not sure what you mean by copper 2 plus reacting. However, copper 2 plus is in an aqueous form. An aqueous form, if it could react, will always react extremely quickly, if it can, if there is an allowable reaction. Because it is in aqueous form, bigger surface area, that kind of thing.
Yeah.
But copper metal, in addition to it being a metal, not a powder, is already slow, and then some more it resists reaction. That it can react, but in a laboratory kind of time, 5 minutes, 10 minutes, it doesn't react much one.
Oh, so copper, the element of copper won't is less reactive than copper 2 plus than the copper ion.
That's the wrong conclusion. That's really the wrong conclusion. Copper given time will react to become copper 2 plus. That means not in lab condition lah. Like if you leave it for 1 day, definitely react one. But copper 2 plus does not become copper. Copper become copper 2 plus. So copper will react given the time to become copper 2 plus.
Ooh.
There is no situation where copper 2 plus will react to become copper. It's a very rare reaction for that to happen. So copper 2 plus is not more reactive than copper. You cannot say that also.
So copper can turn into copper 2 plus with a natural reaction. So like I just don't do anything to it. It will turn
Just
into
give it a long time, right? So does this question give you a long time? I don't know, but assume lab condition, no, assume lab condition, no. So no reaction because very slow. But if you forget to leave and you leave your copper outside in an acid, it will react. That's also not something that you must do. That's a practical knowledge. You cannot do that also.
Oh. So zinc can also turn into zinc 2 plus naturally.
Zinc is reasonably fast. Zinc is reasonably fast. How do you know? 2 chapters down the road. 2 chapters down the road. Okay. Kyoko, are you stuck or are you thinking?
Thinking.
All right. Okay. Wait a minute. The nature of this stationary point. Which question are we in here? Sorry. I'm sorry. You're thinking about the CG question or which question are you thinking about? Okay. Look. According to your visual, right? According to your visual, you want to find point D, right? And you cannot find point D, correct or not? Visually, you didn't reach there. Right? But do you remember what we think we can at least do? We discussed that yesterday, right? We discussed that, right?
Yeah, but after that, what do I do?
Yeah, after the shoelace method, we haven't finished the shoelace method because there are 2 unknowns, correct, right? Yeah, isn't that 2 marks? Like, what do you think? How many marks is that worth if you don't finish up until the current B? Is it like 0 marks?
1.
Then how many marks would you get if you think you just go through the shoelace method and stop in the middle?
0.
Oh my goodness. And why would you think like? You know what? Never mind. Kyoko, your response to hard question is definitely not the right concept. Why don't you skip this question? Okay, you don't get the 2 marks. You don't. After you do all the other question, I promise to just explain you how to do this. Okay? If not, we will be stuck in this question, which is not what we're trying to do. It is definitely a bad habit to break. Please, let's skip to this question and to the next one. Shall we do that? Anyway, you've done the shoelace now, right? Come, let's skip. Go to linear law, and then you'll have more confidence. Okay, so for you, Aiden, why do you think 29 is D?
29 is D because I use my common sense logic. Like, I mean, the gas from like the house comes from a chimney. It usually won't be like so chemistry, like it will be like natural gas like carbon dioxide.
Oh, I'll give you a better reason, but you're correct lah. You're correct. But I'll give you a better reason. Just explain, yeah. So, I'll just explain. Right? Here, calcium carbonate, right? Calcium carbonate, and then what comes out is calcium sulfate, right? That means the calcium here goes to the yellow, right? Correct. Where does the sulfate come from? Well, must be from the flue gases lah, because you don't know what's a flue gases. To be fair, you don't know, fine. But they tell you it's desulfurization. So the flue gas must contain some sort of sulfur, correct or not? Which kind of explains the SO4 lah. Will this be okay? Must be from there lah, something like that. Okay, must be from there. Now, since you know that the sulfur stuff here is acidic, remember, whatever sulfur stuff, sulfur oxide, sulfur dioxide, I mean, for example, the sulfur gases is a sulfur dioxide gas. It definitely contains that. That's what you call desulfurization. I don't want sulfur dioxide, going out lah. I don't want. Now, this is definitely acidic, man. That's what you learned yesterday, correct? Sulfur oxides are acidic. Can?
Yes.
This acidic thing meets a carbonate. Well, again, whether you remember your memorization or not, what happens when acidic meets carbonate?
You will make carbon dioxide.
Yeah, there you go. And water lah, and whatever lah. But that's the point. No? That's your CO2, and that's why your answer is correct lah.
Yeah.
Okay. Different reason, but you tend to get lucky with your guesses. that's fine. Luck is also a skill, right? Okay. Okay. Kyoko, are you stuck with linear law? Kyoko, are you stuck with linear law?
I don't know.
Right. So according to the discussion last time, there's a table, right? Remember, there's that table. V plus 3. Now, to complete that table, you can use a calculator. Go ahead and complete the table, and then you can immediately draw the graph. But if you don't complete the table, the coordinate is not complete. You cannot draw the graph. Make some sense? All right, then please give it a try. You must be rusty. Yep. Go ahead, take your calculator and complete the graph. Complete the table. If you don't know how to use it, please ask me. Today, I'm a bit disappointed because you don't ask me. You just get stuck. Please ask me. Okay? I already say that I will help you, but I have to keep asking you. That's not good. Oh, what? Oh, that's mine, yeah. Okay, balancing is okay. Then hopefully this more question you can do successfully. That would be nice. Eden, are you okay so far?
Yeah, I think I'm all right.
Okay. Oh, ugly number, is it? Ugly number. You're such an ugly number. Hmm. Yeah, to be fair, this question is also no joke one. Wow. another new thing. Wow. If you go, you finish the table, right? Now, again, a revision for you. Once you finish the table, that's all you need to draw a straight line. The coordinates will give you a straight line one. So all you have to do is just put them in. Hopefully you'll see a straight line. That's what linear law means, like we are expecting a straight line. Okay, let's see. All right, sure. All right. And then that's an ugly number, but the MR is correct. The mode is also correct. Sure thing. Good. Kyoko, just to confirm that you roughly know what to do.
Mm.
Okay, that seems like the first coordinate. Okay. Okay, Kyoko, right. Okay, these are the first 2 points. Okay. We're waiting for the third point. If the third point is in a line, then you know you're doing, yeah, you're on the right track. See lah. Your third point on the line. If it is not, don't force it lah. Yeah. But hopefully it is. Hopefully 1.7, 1.7. Come on, 1.7 is, here's 1.7. Sorry, Kyoko, what are you doubting here? Sorry, Kyoko, what's stopping you right now? Kyoko, is it because there is no line in the middle? Is that why you are stopping?
Mm.
Sorry, I can't hear you.
I don't know.
Is it because there is no line in the middle?
Oh, no.
Okay, do you know where's 1.7 then? Okay. Yeah, I think the last one might be tricky. Yeah? Might be. Then maybe for the last one, I help you a little bit, Ken? Unless you are not stuck lah. Let me just confirm. Maybe a bit confusing here. So now this is what I'm going to do. I observe the three reactions. The second one continues to the third one. Second one continues to the third one.
Yeah.
But I noticed that the first one does not necessarily continue to the second one. The first one and the second one doesn't seem to, be related that way. So far, so good.
Yeah. Oh, so I'm supposed to like know what the MG is.
I mean, they do tell you the MG lah. They do tell you, but maybe I'll put it this way. The easiest way I can explain this is that the original MG is split between reaction 1 and reaction 2. I think that's the best explanation. Make sense?
Yeah.
So if I combine 1 and 2, maybe you can see what you're supposed to do. Now I'm just, 1 combined with 2. That's all I'm doing. Okay. So what happened is 5 mg 1O2 plus 1 N2, right? Becomes 2 MgO plus 1 Mg3N2. That's just me combining the two reactions.
You can combine one.
I'm doing this more like mathematically. They happen separately, but they happen at the same time. So from that logic, I'll say I'll just put them all at one go. Okay. It's not that they happen. It's not that they are related to each other, but they happen at the same time, and they're using Mg also. So I guess I can combine them lah, something like that. Yes. Yeah. Okay, so that's for mathematical reasons, not for the chemical reason. In chemical reason, this is not reacting with that. This is, this is wrong, but this is more correct. Fine, no problem. I'm just doing it mathematically. So now the question is, he wants this one, huh? We already have this one, so to speak lah. We already have this one. So I think it makes it easier. Now that I combine them, you can see the relationship between this one and this one, in terms of the balance lah. That's why I combine it for you, I guess. That's why. Hey, no, wonderful, Kyoko. You have a line. That's always a good sign, right? That's always a good sign. Hey, like we are more than 1.5 hours already. Do you want to stop this right now, Kyoko?
Yeah.
Okay, then I'll see you at 5 o'clock. Okay. Okay. Right, Aiden? I mean, time is up, but maybe you want to finish this one first. Yeah.
Okay. the mass of magnesium nitride is still 8.25, right?
Okay, Aiden, are you stuck?
Yeah, I'm still stuck with the thing.
The part 6, right? Part 6, yeah. Okay.
Yeah.
So I will again go back to the mole. I'm not, I don't want the mass of the magnesium nitride. Okay, why am I going to magnesium nitride? Because I know a lot of things about magnesium nitride at this point. So I'm going to list down the mole. Please confirm to me the mole is this one. Okay, fine. Sorry, this one. Correct. That will be the mole.
Yeah.
So the mole of NGO based on this new combined reaction is very simple, right? It should be this guy lah.
Yeah.
Times the MR, which is the MR of MgO will be 24 plus 16, I think. So MR equals to 40 lah, right? Right?
Yeah.
So therefore, I will have my gram here.
Oh, then you minus off this gram.
I minus, oh, sorry, I what?
You use 21.296 minus that answer.
No. Let me see for a while, yeah. You have your 8.25, good. Have, yeah. Oh, he's saying something else, isn't it? Let me think for. The question can be interpreted differently. But this is advanced mode already. This is advanced mode already. Let me think about this question for fun. Anyway, so this is a sec 3. I mean, we almost finished the paper lah on the topics that we're interested, right? So this is a sec 3 paper, which is harder than yesterday's paper lah. Would that be correct?
Yes.
If you go to a prelim question, will it be as hard as this? Roughly already. This should be, I mean, a question, the questions that they give you shouldn't be harder than this. It should just be different, not harder already. For example, in some of the MCQ questions, there's a lot of consideration in choosing an option, and the options can be, a bit misleading us, to choose the wrong options. That's I guess that is a difficult question in exam. It will look like that. Now, at night, you have a choice lah. Yeah, you have a choice. Do you want to try a prelim paper if you are really, if you really want to, right? Or do you want to go to physics? I think at this point your chemistry is how do I say? It's not stable, but you can already continue to do paper. For example, when the school week start, there is nothing from your teacher. We are not lost. We will just do paper. At this point, you're ready to do paper. That's what I feel. So is there a need to do paper at night? No, precisely because of that. Maybe we want to chase physics first until physics also ready to do paper. And then you're happy, lo? School start, nothing happen, just do one paper, just do 2 paper. That's all, do 1 paper, do paper. Then you should be ready for your term 3 exam. That's what I mean.
Yeah.
So it doesn't mean that you're ready for exam. I mean, you still have 2 months before the exam. That's not what it means. But you're reasonably there, you're progressing slowly. Right? Good. Okay. So what is your choice for night? Another paper or physics? Both are fine.
I think physics.
Let's try lo, but physics, I don't know your situation, right? So at night, I'm gonna ask you about your situation lah, this lah, that lah. Okay.
Oh, okay.
Right. Then I'll see you at night. Good job for today.
Okay. Bye-bye.